The American cutlery industry is a quiet giant, valued at over $5 billion. While it may not carry the same traditional prestige as Japanese or Swiss blades, the United States stands among the world's top producers and consumers of knives. Yet few people realize that such a small, everyday tool must undergo an incredibly demanding production journey, from raw material extraction and steel refinement to precisely controlled heat treatment and hand-finished sharpening. In many parts of the world, blade making is considered a cultural heritage, and a single handcrafted knife can be valued on par with high-end works of art. In this documentary, we'll dissect every stage in the making of a knife, from a lifeless steel billet to a cutting edge honed with precision down to the smallest fraction of a millimeter. In the world of culinary arts, a knife is far more than just a tool. It's the line between clumsy and refined, between a simple meal and a true work of art. A professional chef may own anywhere from 8 to 20 different knives, each designed for a specific task, ingredient, or philosophy of preparation. The precision of a single cut can matter just as much as the seasoning of a dish. When working with prized ingredients like bluefin tuna, even separating the muscle fibers and extracting the finest cuts can require up to 6 different knives. Use the wrong blade, and the fish may lose its sweetness, its texture can bruise, or the shape may collapse entirely. Sharpness is essential, but it's the right blade, the right pressure, and the right angle that defines a chef's mastery. Inside a professional kitchen, every knife has a name, a purpose, and a story. And how a chef chooses, holds, sharpens, and cares for each blade says everything about how they treat their ingredients and the respect they hold for their craft. So if it were you, investing in one truly great knife, what would you prioritize? Sharpness, durability, or lightness? The journey to forge a razor-sharp blade begins in one of the harshest places on Earth. Vast open-pit iron mines stretched across barren, sun-scorched landscapes. The essential ingredients for steelmaking, hematite and magnetite, are iron-rich minerals with low impurity levels, ideal for high-grade refinement. Massive excavators dig deep into the ground, stripping away layers of rock and soil to reveal rich, dark veins of iron ore. Once brought to the surface, the raw ore is crushed into finer pieces and enters a complex separation process. Magnetic fields, hydrocyclones, and gravity-based techniques are used to filter out clay, silica, and unwanted minerals, leaving behind only the purest elements. The result is a refined ore with over 60% iron content, ready to be transformed into high-performance steel. Though it's just the beginning of the process, the quality of this ore directly influences the blade's hardness, durability, and ability to hold a sharp edge, all vital traits of a truly great knife. After the ore is refined and enriched, it moves into one of the most critical stages, steel making. This is where raw minerals are transformed into high-value material, tough, durable, and capable of holding a razor-sharp edge. The purified ore is fed into a blast furnace, where temperatures reach up to 1,800 degrees. Inside, the iron melts and reacts with coke, removing oxygen and forming molten pig iron. But pig iron on its own is brittle and unusable for knife making. It still contains impurities like sulfur, phosphorus, and excess carbon. To fix this, the molten metal is transferred to a refining furnace, either a basic oxygen converter or an electric arc furnace. In these tightly controlled environments, impurities are carefully removed, while precise amounts of alloying elements are added. Carbon increases hardness, chromium improves corrosion resistance, and additions like molybdenum and vanadium enhance strength, toughness, and wear resistance. The result is high-grade steel with a stable chemical composition and uniform internal structure. It's cast into billets or round bars, ready to be cut, shaped, heat-treated, and ultimately sharpened into a blade. This refined steel is the silent foundation behind every high-performance knife. After refining, steel isn't yet ready to become a blade. It first needs to be shaped into plates, bars, or billets with precise dimensions suitable for knife production. The transformation begins inside massive furnaces, where steel billets are gradually heated to a point that increases their plasticity without altering their internal structure. Once the temperature reaches the ideal range, each billet is passed through a powerful rolling system. Gigantic steel rollers weighing several tons compress and stretch the metal into thinner, longer strips. Every roll controls width and thickness down to fractions of a millimeter, ensuring the material is consistent for the next phase. As the rolling process ends, the steel is gradually cooled to prevent thermal shock, a critical step in maintaining structural integrity. It then moves to cutting stations. Depending on the design specifications of each knife line, the steel sheets are trimmed using mechanical shears, CNC cutters, plasma, or laser machines. The result is a series of rectangular or wide strip billets, typically between 2 and 6 millimeters thick. Even though it's a transitional stage, this is one of the most error-sensitive steps in the entire process. A single crack during rolling or a cutting deviation of just a few millimeters can render an entire billet unusable. But those that pass inspection are now ready to begin their transformation into fully forged knife blades. From pre-cut steel billets, the true shaping of a knife blade begins. This is the stage where a blade's basic geometry is formed, setting the foundation for all later refinements. In modern factories, this process is typically carried out by high-power laser cutters, CNC machines, or hydraulic presses. Every move is controlled by pre-programmed CAD files that define the exact design of the blade. As the steel sheets move down the line, each billet is cut into its final outline within seconds, executed with near-perfect precision. Every curve, bevel, length, width, and tip angle is calculated in advance and executed automatically. A single system can produce hundreds of identical blades per hour. This level of uniformity is essential for large-scale production, where consistency and tight quality control are non-negotiable. But on the opposite end of the spectrum, traditional blacksmiths follow a completely different path. In artisanal workshops, the billet is first heated over a charcoal forge until it glows bright orange. Then it's laid across an anvil, where the blade is shaped entirely by hand. Each hammer strike doesn't just shape the metal, it also compresses the grain structure inside, forging a kind of natural toughness that machines struggle to replicate. After rough forging, the blade goes through an initial grind using a belt sander or whetstone. This step removes burrs, flattens surfaces, and fine-tunes the shape in preparation for the next critical phase, heat treatment. To achieve the ideal hardness, edge retention, and resistance to chipping, a knife blade must undergo a crucial thermal process known as heat treatment. The blade is slowly heated inside a furnace, with the temperature gradually rising until it reaches between 800 and 1,050 degrees Celsius, depending on the type of steel. At this critical range, the steel's microstructure begins to transform. This internal shift allows the metal to become significantly harder, without altering the external shape of the blade. Once the target temperature is reached, the blade is rapidly cooled by quenching it in oil or inert gas. This sudden change locks in the new crystalline structure, solidifying the steel into its hardened state. But the speed of cooling must be tightly controlled. Too fast and the blade could crack or warp. Too slow and the hardness won't meet the required standards. When performed correctly, this process brings the blade to a hardness rating between 60 and 62 on the Rockwell scale, ideal for professional-grade knives. After hardening, the blade reaches impressive levels of hardness, but with a hidden weakness, brittleness. At this stage, the steel is highly vulnerable to chipping or cracking under sudden impact. To counter this, the next step is tempering, a vital heat treatment designed to restore toughness and stabilize the steel's internal structure. During tempering, the blade is placed back into a furnace and held at a lower temperature, typically between 150 and 250 degrees Celsius, for 1 to 2 hours. This controlled heat is low enough to preserve the blade's hardness, yet sufficient to release internal stress built up during the quenching phase. Inside the steel, microscopic crystals begin to shift into a more stable configuration, increasing ductility and resistance to shock. For premium knives, this process may be repeated twice to fine-tune the steel's mechanical properties. Once tempering is complete, the blade is left to cool slowly at room temperature, ready to move on to the next defining stage in its transformation, sharpening the edge. This isn't just about smoothing the surface, it's where the blade truly earns its identity. Before sharpening, many workshops submerge the blades in a solution of water and specialized oil to remove any residual oxide scale from heat treatment and to cool the steel before it touches high-speed grinding wheels. In industrial settings, each blade passes through a multi-stage sharpening line, starting with coarse grinding, then medium, fine, and finishing with a final polish. Each wheel is calibrated with specific angles, speeds, and pressure to ensure consistent edge sharpness without warping the blade. In traditional blacksmith workshops, sharpening isn't just a skill, it's the heart of the craft. Artisans use motorized wheels or hand sharpen on natural whetstones, maintaining a precise angle, usually between 15 and 20 degrees. Sharpness is felt through each pass and often tested by shaving arm hair or slicing a single strand of hair. If the blade defines sharpness, the handle defines how it feels in your hand. Depending on its intended use, the knife handle can be made from exotic hardwood, engineered plastic, stainless steel, or high-end composite materials. Each option brings its own balance, grip, and aesthetic. The crafting process begins by cutting raw blanks and drilling pinholes for assembly. Then the surface is carefully sanded and treated with oil, wax, or anti-slip coatings, enhancing both durability and grip comfort. A well-crafted handle isn't just about looks, it's what connects the user to the tool, turning each cut into a controlled and confident motion. Once the blade and handle have been individually crafted, the next step is assembly, where the two parts are joined into a single, unified tool that feels both solid and balanced. In industrial production, this process is carried out on semi-automated lines. The blade is inserted into the handle and secured using specialized industrial adhesive. Then, it's clamped under pressure to ensure a tight seal and long-term durability. Some designs also incorporate metal pins or rivets to reinforce structural integrity. In contrast, traditional workshops treat this step with meticulous care. Craftsmen inspect every junction, adjusting the tang until the fit is perfect before applying glue or hand-setting pins. Once assembled, the knife is clamped and left to rest for several hours, sometimes overnight. Finally, the joint between blade and handle is hand-polished to create a seamless finish. If the handle is misaligned or loosely attached, the entire knife loses its balance and fails to meet the standards for use. Before being packaged and shipped, every knife must pass a rigorous quality control process. It begins with a hands-on inspection. Skilled workers visually examine the straightness of the spine, the consistency of the grind lines, the smoothness of the finish, and the feel of the handle. Each blade is tilted under bright light, and the edge is carefully run through fingers to detect even the tiniest burr or imperfection. Next comes performance testing. Blades are put to the test by slicing through standard materials, paper, meat, wood, or rope, to assess their sharpness and precision. Some factories go further, using force gauges and edge angle sensors to measure cutting efficiency and ensure the grind is within precise tolerances. Knives that show the slightest warping, misalignment, or flawed edges are immediately pulled from the line or sent for recycling. Only those that meet flawless standards are cleared to leave the factory. In the final stage, the finished knife receives its brand mark, an engraved logo that serves not just as a symbol of identity, but as a statement of craftsmanship, origin, and quality assurance. Once marked, the blade is carefully cleaned to remove steel dust, coated with a thin layer of anti-rust oil, and wrapped in protective materials like plastic sleeves, moisture-resistant paper, or cushioned foam to shield the cutting edge. Depending on the product tier, the knife may be packaged in a branded cardboard box, a leather sheath, or a premium wooden case. Some brands include user manuals, warranty cards, or a personal note from the maker. For many high-end manufacturers, the box is designed with the same attention to detail as the knife itself, elevating it into a gift-worthy object of value. From what was once an inert block of ore buried deep underground, shaped by blazing heat in the skilled hands of craftsmen, the knife takes form, sharp, balanced, and built to endure the test of time. Every blade is a fusion of carefully chosen materials, precision-controlled technology, and traditions passed down through generations. If this video gave you a new perspective on the knife in your own kitchen, leave a like and subscribe. We'll continue uncovering the hidden stories behind everyday objects, things that may seem ordinary, yet carry within them an extraordinary world.